Welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 3, part A from the June 2023 Pure Mathematics P4. This is the paper 4 from the Edexcel syllabus, the International A-Level syllabus, and we have a question here. Part A of question 3 is about partial fractions. So we have to take this fraction and split it up into separate fractions. It's like kind of like the opposite of when we add two fractions together. Okay, now when you have a partial fraction to split up, the first thing you always do, you have to check to see, is the fraction an improper fraction? Okay, now an improper fraction is when the order of the numerator is the same or greater than the order of the denominator. Okay, what does that mean? Well, it means that the highest power in the numerator of the variable, like here the x, has a power of 1 on the numerator. And the denominator, if you were to expand it, the highest power of the variable will be 2, it will be x squared. So the order of the numerator is 1, the order of the denominator is 2, so it is a proper fraction. It's not an improper fraction. It is proper because the order of the numerator is less than the order of the denominator. So we don't have to worry about any whole number parts, quotient parts, which we would deal with if it was an improper fraction. We don't have to deal with that. Okay, so we can just split this up as basically, we can say 8x minus 5 divided by 2x minus 1 times 4x minus 3 is identical to a linear constant, a constant over 2x minus 1, because it's going to split up into two fractions which are both proper fractions. And for these to be, these two fractions to be proper fractions, the numerator is less than the denominator. So and that can only be a constant, right? These are the type of partial fractions we will deal with in P4. All right, so here we have this proper fraction splitting up into two separate proper fractions. It's like we're taking a fraction and we're splitting it up. It's like opposite of adding them together. The next step is for us to take this common denominator, which is 2x minus 1 times 4x plus 3, and multiply both sides of the inequality by that. So if you multiply this side by that, you get 8x minus 5. It cancels out. If you multiply this term of this side by that, the 2x minus 1 part cancels out, and you're left with 4x minus 3 plus, and b will be multiplied by 2x minus 1. Okay, b will multiply by this one, because when you multiply this by that, the 4x minus 3 part cancels out, you're left with 2x minus 1. So now we have a variety of ways to solve this. Now, because the numbers are a bit, I think you could use substitution. All right, one way you can go by dealing with this is by using substitution, finding a value of x that you can put into one of these brackets that will eliminate that bracket, make that bracket 0, which means that the letter that's multiplied by the bracket will be eliminated. So the most obvious one here, 2x minus 1, what makes that bracket 0? When x equals a half. So if I substitute x equals a half, okay, it's not going to make this very complicated, because 8 times a half is 4. That's easy. 8 times 4 times a half, that's going to be 2, which is not bad. That's fine. And of course, this is going to become b times 0. So you're left with basically 4 minus 5 equals 8 times. Now 4 times a half is 2 minus 3. So you'll end up with minus 1 equals minus a. Therefore, a is equal to 1. Okay, a is equal to 1. Now, you could kind of almost see that, because if you were to expand this, you'll have 8x over 8x squared if you expanded this. So the leading, the 8 divided by the 8 gives you 1. That kind of like will normally happen. The number that's multiplying the highest power on the numerator and the one multiplying the highest power on the denominator, when you divide them, you normally get, okay, one of those. But that happens sometimes. Now, I don't think we can rely on that, but that seems to happen. But we're not sure which one it will be over, so we can't really rely on that. So just ignore what I said there. Don't worry about that. Okay, so now, so A equals 1. Now, next step is to find what B is. So we could do something here. We could find something that eliminates this bracket. Now, the number that we would have to use, is it a number that's going to make life difficult for us? Let's say it's going to be x equals 3/4. Now, using 3/4 in these two is not going to be too bad. I mean, you're going to end up with a fraction here. That's not bad. It's probably easier than doing another method. There are other methods which I'm going to show you also. But x equals 3/4 is a pretty good way to go. So this was x equals a half. And now we're going to use x equals 3/4. When you use x equals 3/4, you have 8 times 3/4 minus 5 equals a times, this is going to become 0. That's the reason why we chose 3/4. That will be 4 times 3/4, which is going to give you 3, minus 3, which is 0, plus b times, now this is going to be 2 times 3/4 minus 1. So here we'll have the 4 and the 8 cancel out, leaving you 2. That will be 6 minus 5 equals, that's 0, that's gone. And that's going to be 2 times 3/4. So the 2 and the 4 cancel, leaving you with 2. So it's going to be 3/2 minus 1 times b. Okay, that's how much b you'll have there. All right, so this is going to give you 1 equals, now 3/2 minus 1 is a half. Therefore, b is going to be equal to 2. So we have a equals 1 and b equals 2, okay, as our two coefficients, our two, the numbers which are the numerators of these two fractions. That's one method of doing it. We can also do it in another method. So if we start off with the same stage, 8x minus 5. So this is a method 2. I'll show you another way as well, just so that you may be comfortable with it. So a times 4x minus 3 plus b times 2x minus 1. So one way we can do it is we can compare the coefficients of the constants. Okay, so you can see here, if we look at this side, you have the highest power is the highest, x term is x to the power of 1. So if you compare the coefficients of x on both sides of this equation, or this identity, you have 8x on this side, so there's 8x's on this side. And on this side, you have 4ax's plus 2bx's. Okay, so that's one equation we formed. We can also look at the constants. If we look at the constants on this side, you have negative 5. And here you have minus 3a. And you have minus b. Okay, so you have two equations now. And you can solve them simultaneously. So for example, if I multiply this equation by 2, I'll have minus 2b. And there will be minus 6a. And that will be minus 10. So if I take these equations with each other and subtract them, or add them in fact, if I add this equation with this equation, okay, then what will happen is you'll have, this gives you 0b, you'll have 4 minus 2 minus 6a, which is minus 2a, and 8 minus 8, you're adding them together, right? So it's 4 minus 6a, and you're adding these together, 8 plus minus 10, that's minus 2. So therefore, we're going to have a equals minus 1, plus 1, sorry, because you have a equals minus 2 divided by negative 2. So you have a equals negative 1. Okay, so A is, positive 1. So that's the answer for A. And then we can put that into one of these equations. For example, we can put it into this equation. We can say 8 equals 4 times 1 plus 2b. So 8 minus 4 is 4 equals 2b. So 4 divided by 2 equals b. So b is equal to 2. So whichever way you want to do it, comparing coefficients or substituting values which eliminate one of the letters by making the brackets multiplying into 0, perfectly fine. But in the end, we're going to write our answer as 8x minus 5. So 8x minus 5 divided by 2x minus 1 times 4x minus 3 is equal to a, which is 1 over 2x minus 1 plus 2b, which is 2 over 4x minus 3. So the a, okay, the a is the one that's over the 2x minus 1, and the b is over 4x minus 3. So here is the answer to part A. We have split this into a pair of partial fractions. We have split it up. It's like the opposite of adding. If you were to add these fractions together, you would get that. Here, what we've done is we've done the reverse process. We have split up the fraction into two parts. So there is the answer to 3 part A. Okay, so I think we might have to use this. Okay, so I'm going to copy this. And now for part B of question number 3, it says hence, and we should all know by now that the word hence means using what we just found in the last part of the question. Find the integral of f of x with respect to x. So f of x, we expressed it as partial fractions, and in this form it's easy for us to integrate as we have to do. All right, so we're going to now integrate what we found. So we found the integral of, you must put it in brackets because you have separate terms here, 1 over 2x minus 1 plus 2 over 4x minus 3, and that all must be integrated with respect to x. So to integrate something like this, what we realize here is this is of a particular form where we can reverse the chain rule. Now, what we should understand is when you differentiate something like the ln of some function of x and you differentiate with respect to x, you always end up with 1 over the thing that's inside that function. So 1 over whatever's inside the ln function. But then because of the chain rule, you multiply by the differential of what's inside the function. So you end up with f dash of x over f of x. So if you have the numerator as some multiple of the differential of the denominator, you can reverse the chain rule. So if you can see this pattern here, you can reverse the chain rule. So if we look at the denominator of both of these, if you differentiate them, you get constant. This gives you 2, this gives you 4. On the numerator, you have a constant, which is some sort of multiple or factor of the, the constant that you get. Therefore, you can simply just, use this, reverse this. Okay, so you can reverse this and you can call it the ln of. All right, so what we're going to do here is we're going to reverse the chain rule by writing this as the ln of the modulus. You always write the modulus for reasons which maybe I'll explain in a different video. Don't really need to go into it for now. Of 2x minus 1 over, and then you divide by the differential what's inside the function. When you integrate a function, you integrate the way the function integrates. This one integrates by using ln, and then you divide by the differential what's inside the function. Plus, similarly here, this time you have 2 times because there's a 2 on top. It's like you got 2 times 1 over 4x minus 3. So you have 2 times the ln of the modulus of 4x minus 3. And then divide by the differential what's inside the function, which is 4. And then because it's an indefinite integral, you have to put plus c at the end. Okay, so this will give us the ln. There will be a half of the ln of the modulus of 2x minus 1 plus a half of the ln of the modulus of 4x minus 3, and then you're going to have your plus c, and there's your answer to this question. Now, in this particular question, we're told that x is greater than 1. Okay, that we were told that x is greater than 1. And we know that we're putting these modulus signs here in case what comes inside here is negative. Now, let's see what values of x, well, x has to be for these to not be negative. So we can see for 2x minus 1 to be positive, to be greater than 0, if you rearrange this, you have 2x equals 1, so 2x is greater than 1, so x is greater than a half. So whenever x is greater than a half, this is going to be positive. So this is always going to be positive. It's never going to be negative with the domain that we have. Therefore, we can rewrite this as a half times a ln, and we can just use a normal bracket because there's no chance of this becoming negative because we can only use x values, which will cause this to be positive inside here. All right, and for this one, 4x minus 3, for it to be greater than 0, then x has to be greater than 3/4, which the x values we can use are. So this one similarly can be written as a half times a ln, and you can use brackets 4x minus 3 and plus c. So you can write your answer like this. If you write it both ways, it's fine, but this is just probably will help us later on in this question where we don't need to use the modulus signs, okay, because we know that what's inside there can never be negative, so no need to use it because our x value that we can use are always going to be values which will cause these both to be positive. Right, now we're going to go on to part C of the question. So it says use the answer to part B. So I'm just going to take this answer. Let me just take this answer that we got here together. Okay, use your answer to part B. So this is now the integral of f of x with respect to x without any limits. Right, so use this answer to part B to find the value of k for which the integral of f of x with respect to x between the limits now of 3k and k is half ln 20. Okay, so now what we can do is we can say, okay, this is the integral, all right, and we don't need the plus c, so I'm going to write this as a half times the ln of 2x minus 1 plus a half times the ln of 4x minus 3. We don't need the plus c, but we need the square brackets. If I use the limits 3k and k, it's going to give me a half ln of 20. Now, I'm going to make life a bit easier for us. So what I'll do is, I can see there's a common factor of a half, so I'll take that out first. Okay, and I can also see that inside here, we have an addition of ln. So once you're taking the half out, you'll have ln 2x minus 1 plus ln 4x minus 3. So we can combine them as a product. So we'll have ln of 2x minus 1 times 4x minus 3. All of that is inside this ln, so I'll put this in an outer bracket like that. Okay, and I have my limits 3k and k, and I know that's going to give us a half times the ln of 20. Now, what I can do next is I can multiply both sides of the equation by 2, which will cancel out the halves. And then I've got this left. Okay, so now I can put the values of k in here. So I have ln, and then I'm going to have 2 times 3k minus 1. Then I'll have 4 times 2k minus 3. Okay, minus, I have the ln. I'll do the same thing now with k. So I'll have ln times, it'll be 2k minus 1. And that will be 4k minus 3. Just in place of the x, write k. Okay, so I have ln of this and ln minus ln of that. And that will, and we know that that's equal to ln 20 now. That's equal to ln 20. So I can combine these two together. I can't get rid of these lns yet because this is not one ln term. I have to make it into one ln term. So I can combine these together using the subtraction law. So I'll have ln of, let me do this in one step. That's going to be 6k minus 1 times, that's going to be 8k minus 3. Sorry, that's not me. That's a 3k. That's a 3k. Sorry about that. What am I doing? I've come back to correct it now. Some of you might have thought I was got it wrong, but I found it in the end. That's a 12k. That's supposed to be 3k, not 2k. Minus 3. You've got to be very careful not to make silly mistakes here. Over, and I can use this. You know, I'm using the power law. Ln of a minus ln of b is ln of a over b. That's what I'm doing. So it's the ln of all of this over this. Okay, so you're going to have 2k minus 1 times 4k minus 3, and that's equal to ln 20. Now, because I have one ln term equals, and the ln term, they're both equal to each other, I can basically get rid of the lns now. Some people will say raise, put these to the power of e on both sides or something like that, and they cancel out. But it's fine. Ln of something equals ln of something. That means those two things must be the same thing. So now I have this equation, 6k minus 1 times 12k minus 3, and I can, let me just take it step by step, and 2k minus 1 times 4k minus 3 is equal to 20. So now I can multiply both sides by this denominator, in which case I'll get 6k minus 1 times 12k minus 3 is equal to 20 times 2k minus 1 and 4k minus 3. So I can expand the brackets. I'll end up with a quadratic now. So 6 times 12, 72. So 72k squared minus 18k minus 12k plus 3 is equal to 20 times. You're going to have 8k squared minus 6k minus 4k plus 3. So this is going to give us 72k squared minus 30k plus 3. And this is going to be 20 times 8k squared minus 10k plus 3. So 72 squared minus 30k plus 3 is equal to, and this is 160k squared minus 200k plus 60. Okay, now let's bring the k squares together on the same side. If you have 160k squared minus 72k squared, that's going to be 88. Let's make sure. 160 minus 72. That's 88. So you have 88k squared. And here you got minus 200k plus 30k. That's minus 170k. And you have 60 minus 3, which is 57. And that's equal to 0. So now we can find what k is. We can solve this quadratic equation. Now, I don't think it's that easy to factorize. It might be doable, but it's really big numbers we're going to have to use. You have to find two numbers, add a multiply to give you 88 and 57. The product of 88 and 57. And then you're going to work from there. So it's going to be a bit difficult, I think. You can't simplify it because 2 isn't a common factor. 3 is not a common factor. So yeah, I don't think you can. So let's just use this formula. The easiest thing here would be to use this formula. So k equals minus b. So it's going to be minus 170 plus or minus the square root of b squared, which is minus 170 in bracket squared, minus 4 times a, which is 88, times c, which is 57. All of that over 2 times a, 2 times 88. So let's see what that gives us. That's going to be brackets. It's going to be 170 plus first the square root of 170 squared. It's going to become positive 170 squared anyway. Minus 4 times 88 times 57. All over 2 times 88. Which gives us 3 over 2. So k equals 3 over 2. And let's see if there's another value of k. I know there's only one value of k. It says find the value of k. So let's see what the other answer gives us and see if we can understand what that refers to. Okay, so we're going to put a minus sign now. Instead of that plus there. Minus b plus. Now we're going to put minus. That gives us 19 over 44. Now, it says find the answer. And in fact, the only answer is k equals 3 over 2. This is not an answer. And the reason we can say it's not an answer is because we know the value of x, which k is representing here, has to be greater than 1. Okay, so the value of x has to be greater than 1. All right. So we're going to reject this answer. Okay, because k is going to be a value that causes this to become. If you put k equals 19, let's see. If we put k equals 19 over 44, we know, we just worked it out that k has to be greater than 3/4 and get greater than 1/2. We mentioned that earlier, right? So if I put the value of k in here, okay, which is going to be, in fact, this is not, the reason I mentioned here is not this. You wouldn't say this. You would say if k is a value, okay, k causes this function to become undefined. If I use k as what was the value we got here? 19 over 44. That's less than 1/2. Okay, that's less than 1/2. K has to be greater than 3/4 in us for us to be getting a proper solution. So k, okay, cannot be equal to 19 over 44, as it will cause f of x undefined. Okay, so that's basically what we can say about this question, and I hope that was clear. Other questions from this particular paper can be found in the playlist that will appear in this top right corner at the end of the video. Other questions from this topic, which is all about integration by parts, partial fractions and integration, not by parts, just integration, can be found in the playlist over here. And you can subscribe to my channel by clicking on this link. And if you would like to see a video which tells you how to use my channel to find what you're looking for, you can click over there. Thank you for watching and see you soon.